All right, we're going to move into lesson 10.5 today on using the distributed property. It's kind of a misleading title. Actually, we're going to be using the distributed property in reverse, or the reverse of the distributed property, to help us begin factoring. All right, so really today we're going to be factoring polynomials by using the distributed property. That's probably a more accurate title. Okay, so factoring using distributed property. First of all, we'll review the distributed property. If you remember, the distributed property that we've been working with recently is when I take a monomial and multiply it by a polynomial, or in this case, a monomial times a binomial. We should all know that the distributed property means we're going to take that monomial and multiply it by each of the insides. So it's going to be 5 times x plus 5 times 4. And then we're going to simplify that to get 5x squared plus 20x. So there's our simplified answer using the distributed property. Okay, what we're going to do today is factor. So factoring is basically, I'm going to give you this, and you're going to work this process backwards to give me this. Okay, so it's the process, factoring that is, of expressing a polynomial as a product of monomials and polynomials. So just to show you again, here's a polynomial. We're going to work this process backwards to get it to become a product of a monomial and a polynomial. So this 5x squared plus 20, we're going to change it into 5x times x plus 4. That now is a product. And there's a powerful property called the zero product property out there that we will use this for. So it's very important that we can take a polynomial and write it as a product. Okay, so we're going to be using the reverse of that distributed property today, and we're going to be taking out GCF's, greatest common factors, and rewriting them as products. Okay, so like I was showing you in the example, what we're going to work on today is I'll give you this. What you're going to have to do is look at it, and that we got two terms, and you got to pick out the GCF of the two terms. So what's the largest number that will divide each of these evenly? Well, it's 5. And then what is the highest exponent of x they both have in common? Well, they got x to the first is the highest they have in common. This has got 2 x's. This has only got 1. So at most they have a 1. So your GCF is this 5x that you see right here. Okay. So I'm going to take the 5x out of each term. So I'll have 5x times x. That'll give me the 5x squared. 5x times 4. I know 5 times 4 is 20. So that's what I need here. And that will bring me to my conclusion, 5x times the quantity of x plus 4. Now I'm going to explain this in a lot more detail in a second, but that's just showing you that it's the same steps in the reverse order. Okay, I'll give you more detail. Don't worry about this. One thing you got to understand is you always have to completely factor it. And what that means is when you completely factor it, is there can be no remaining common factors in the polynomial once you take out the GCF. And I'll talk more about examples of that. So you just can't take out the first thing you see in common and use it. Like in this case, I just can't take out a 5. It's got to be 5x. It just can't be x. It's got to be 5x. It's got to be the biggest common factor I can take out of both of these. Okay, so it's always got to be completely factored, which means we take out the biggest we can possibly take out. Okay, let's start by just finding common factors for monomials. All right, and I'll teach you about the process that we use here. So if you were given 10b squared and 6b squared, and you were asked to find the greatest common factor, and we're going to use this in a second to help us actually factor this. Right now, we're just practicing finding it. Okay, so the way you start is you look at the number part, the coefficient. What's the largest number that you can divide both 10 and 6 by evenly? Well, that should be a 2. Okay, that's the biggest number that 10 and 6 can be divided by evenly. All right, and now you go to the variable. Once you do the number part, get your number, you go to the variable. And you're going to take any common variable to the highest power you can take it. So these both have a b squared in them. So that means I can factor out a b squared because they both have it in there to take out. So in this problem, our GCF would be 2b squared. 2b squared is the greatest number that can be taken out of these two. Okay, let's move over to the next one here. So I got 12a squared and 20a to the fourth. So start with a number part. I know they can both be divided by a 2, but is there a bigger number that can divide them both? Well, the answer is yeah. They can both be divided by a 4. Okay, 4 is the greatest common factor. 2 is a common factor, but you got to get the biggest. All right, so 4 will divide each of these evenly, so that's your number part. And now you move to the variables. Well, they both have a's in them. This is a squared, this is a to the fourth. I got to take out the most that they have in common, which is squared. There's two a's here, there's four a's there, so they both have at least two a's in them. So that's the most I can take out. So the GCF here is going to be 4a squared. And you'll see how this fits together in a second. Okay, let's do a couple more. Look here, we got 8a squared and 10m to the fourth. So look at the coefficients first, 8 and 10. What's the largest number that can divide them both evenly? Well, it should be a 2. I know 4 can divide this one evenly, but it can't divide 10 evenly, so it's out. It's got to be a number that can divide them both. So 2 is your number. Now move to the variables. This one has A's, this one has M's. They're not the same variable, so I can't take anything out variable-wise. So the GCF for these two terms is just the number 2. Okay, the GCF can just be a number, it can be just a variable, or like you've seen up here, it can be a product of numbers and variables. It all depends on what you're given. Okay, now I got 3 terms to consider. Okay, still do the same thing. Look at the numbers first, 20, 12, 8. I know they can all be divided by a 2. However, that's not the biggest. They can also all be divided by a 4. And that is the biggest. So 4 is your number. Now, variable-wise, I got x squared, x to the fourth, x. So at most, they all have at least one x. So 4x is our GCF. It's the largest number, and it's the variable to the lowest power, really, that they all have in common, right? Last couple here. So now they've kind of added a little bit to it, but you still just do it piece by piece. Okay, let's take a look at the first one here. So go to the number first, 30 and 18. Well, yeah, they can both be divided by a 2. That goes as much there. Now, but what else? What other common factors are there? Well, the biggest common factor is 6, right? 6 goes into 35 times, 6 goes into 18 3 times. All right, and then if you heard me say 5 and 3, nothing divides those two the same, so 6 is your biggest. So 6 is the number. Go to the variables. I got y to the fourth over here. It doesn't matter the order they're in, by the way. I got a y to the fourth and a y to the second. So at most they have y squared. I got a u to the sixth and a u to the seventh. So at most they have a u to the sixth. This one has v's in it. This one doesn't. Well, it's got to be common to both to take it out. So no v's come out. So your answer here is 6y squared u to the sixth. That's the largest common factor of both. Last one here. So 15 and 30, I think a 5 right away. 5 will divide them both. However, 15 actually will divide 15 once. 15 will divide 30 twice. So in this case, this number is actually your GCF number, 15. Then go to your variables. I got x to the fifth, x to the fourth. So they at most have x to the fourth, v to the fifth, v to the sixth. So they at most have a v to the fifth. I got y squared, but there are no y's here to match with it, so the y's cannot come out. So 15x, oh boy, that should say x to the fourth, my mistake, v to the fifth. So that should be x to the fourth. All right, so that's how we look at the numbers and pull out the GCF, and I'll show you now how it all fits together. Okay, now notice now this is a polynomial. I'm adding these two together. In the last slide, if you go back and look, those are just a list. Those weren't added together. So this is actually a polynomial, and we want to use the distributive property in reverse to factor it. Factor again means to write it as a product of a monomial times a polynomial. All right, so first things first, what is the GCF? Well, I got 12 and 16. So what's the largest number that divides both 12 and 16 evenly? I know 2 is one of them, but I think there's a bigger one, and that would be 4. All right, and now go to the variable, a squared and a. So they at least have an a in common. This one has 2, but this only has 1. You got to take out the least of those. So 4a is our GCF. Okay, now what are we going to do with the GCF? Well, what happens is our GCF is going to become a number that we're going to, or the number that's common to both of these. And we're going to multiply now to create the original problem. So let me show you what I'm saying. So 4a times what number equals 12a squared, our first value? Well, 4a times 3a. 4a times 3a would give you 12a squared. So this product is equal to the first term plus. Now, what would I multiply 4a by to get 16a? Well, that should be a 4. 4a times 4 is 16a. Okay, so now what we've done is we've taken each of these two terms and written them as a product. And in that product, we have the same GCF. Okay, so now the last step in the process is to actually use that distributive concept. So, when I look at this term and this term, what do they have in common? Well, they have 4a. So I'm going to pull that out of each of them. When I pull it out of each of them, what's left? 3a plus 4. So if you look at this, if you were to distribute now, 4a times 3a is 12a squared, 4a times 4 is 16a. So this product is equal to the original number, or to the original polynomial. So I've now factored that. So 12a squared plus 16a factors into 4a times 3a plus 4. Okay? So this, if you distribute it, is equal to the original. Okay, let's do another one here. So looking down here, I got 33n cubed minus 121n squared minus 11n. So I got three terms. Okay, look at the numbers, 33, 121, and 11. So the largest number that divides them all would be 11. And then the variables, I got n cubed, n squared, and n. So they at least all have an n. So 11n is my GCF. Now what we're going to do is we are going to write each one of these original three numbers as 11n times whatever we need to make it equal each of those originals, because 11n is my GCF, so it's a number that could divide each of those evenly. So let's take a look. Okay, if I take 11n times 3n squared, so 11 times 3 is 33, n times n squared is n cubed. So 11n times 3n squared is equal to my first number in my polynomial. So this product equals this number. Okay. Now notice that there was a minus sign, so I put a minus sign here. So it's minus 11n times. Now what do we got to multiply 11n by to get the 121n squared? Well, I got to multiply it by 11n also. So now let's take a look. This negative 11 times 11 is the negative 121. N times n is the n squared. Okay, so the product of these two equal my middle number. And now 11n times what will give me 11n? Well, you got to be careful here. You do have to include the 1. Okay, negative 11n times 1 is negative 11n. Okay, and that has to be there because it's got to be in my factored answer. So what we're going to do to factor is we're going to take this GCF that you see in each one of these, and we're going to put it on the outside of the parenthesis. So we're factoring this 11n out. And when I factor it out, what remains underneath, or what remains here, is 3n squared minus 11n minus 1. So we've now converted this trinomial into this monomial times this trinomial. Okay, so we've written this as a product. Now, distribute that through. 11n times 3n squared, 33n cubed. 11n times 11n, 121n squared. 11n times 1, 11n. So this product of this monomial times a polynomial is equal to the original. Okay, and it's going to be this process over and over and over again, working on that. Okay, we'll do another one here. This is a little bit more complicated. We still got three terms. Okay, we still find the GCF first. So what's the GCF? Well, start with the numbers: 20, 45, 35. The largest number that will divide all of them evenly is a 5. Okay, go to your variables: x squared, x squared, x squared. So they all have an x squared. That can come out. Go to the y's: y squared, y, no y. So they don't all have a y in common, so that can't come out. So my GCF is 5x squared. Next step is to write each of these as a number times 5x squared so that I can factor it. So 5x squared times what number will give me 20x squared y squared? Well, 4y squared, right? 5 times the 4 is the 20. X squared times y squared is x squared times y squared. So I needed 4y squared to multiply by 5x squared here. What do I multiply 5x squared by to get the second number? Well, negative 5 and 9 is the negative 45. X squared times y is x squared y. So I needed 9y to multiply by my GCF to get that number. Okay, what do I multiply 5x squared by to get 35x squared? Well, just a 7. 5 times 7 is 35 times x squared is 35x squared. So I've taken my GCF and I figured out what number I'd have to multiply each of these by to get the original. And now we're going to factor it out. Factor it out means out of each of these terms, I'm pulling that 5x squared out. What I have to write in the parentheses is what remains, 4y squared minus 9y plus 7. If you distribute 5x squared through this parenthesis, you will get this answer back. Okay, another one. 14a squared b squared c plus 6ac squared minus 10ac. First things first, what's the GCF? So the numbers 14, 6, and 10. GCF should be a 2. Variables, a squared, a. So they at most all have one a. B squared, no b, no b. So we can't take any b's out. And then a c, c squared, c. So they at least have a c in common. So 2ac is the GCF. That's the biggest number that will divide each of those. So now I got to write it so that we have 2ac times whatever I need to make it equal this first one. So that should be, that should be 7b squared. Okay, 2 times 7, 14. That should be an ac squared, huh? I messed that one up. That should be 7ac squared. All right, the second one should be a 3c, right? 2 times 3 is 6. C times c is c squared. And the last one should be my dots are out of line here, 5, my circles. 5 times 2ac is 10ac. So my mistake here is there should be an a here. Okay, so imagine that there's an a there and I didn't make that mistake. All right, next step is to take out my common factor of 2ac. Oh my goodness, another mistake. Take out my common factor of 2ac, and this should say, man, I made a mistake. I'm sorry. This should say 2ac times a quantity of 7ab squared plus 3c minus 5. Okay, not a good example there. I kind of messed up. The first three are great. That one wasn't good. Okay, tonight's homework, you're going to go through and pick out GCFs like we did in our first slide, and then you're going to do some factoring, which is taking the GCF out and rewriting it as the GCF times a product. Okay, so study those notes, take a look at things. There's more things you can look at on the McGraw-Hill website itself where your textbook is. So if you need extra help, go there, and I will let you get started.